So this is unit 7, day 2. We're still going to do this week is we're going to know how the exponent rules are used to simplify expressions. We're going to be able to understand that the rules only affect the like bases, and we're going to be able to simplify expressions using the exponent rules. So right here, this is just a warm-up. So I'm going to leave you alone and pause it. Hopefully you pause it as well, and then come back and unpause it, and you'll have the answers. And hopefully you got them right too, okay? Please practice this on your own. You need to be able to just a quick review, okay? Okay, hopefully you got the same answers that I did. All right, let's move on. So we're going to write the expression below in the expanded form. This is being raised to power. So it's an exponent inside of with the parentheses. So that just means that this is the number of times that parentheses is going to repeat. Okay, so I'm going to get, remember now that I'm multiplying, I can go ahead and add these. So that's 2 plus 2 plus 2 is 2 plus 2 is 4 plus 2 is 6. Okay. This is going to have to, it's going to be a little weird because this is the only way I can do it. It's a lowercase n. Sorry. Three times. I'm going to add the 8. 8 plus 8 is 16. 16 plus 8 is 24. And I know I'm going to have to make this box a little bit bigger to be able to fit. And then this is 5y 2 times 5y, 5y. So according to the product rule, I'm going to multiply the 5s and leave a space for the y. 25. There it goes. And then 1 plus 1 is 2. X squared. I'm going to put the little exponent from here. I'm going to show that 4 times. Two, 3, and 4. I add the exponents. 2 plus 2 is 4, plus 4 plus 2 is 6, and 6 plus 2 is 8. Here we go. All right, so we're going to compare them like we did last time. When an expression is raised to a power, let's figure out what you can do. It says that you can multiply the exponents. 3 times 2 is 6, and we got 6 when we added. 8 times 3 is 24, and that's what we got when we added. 2 times 1 is 2, yeah. And then 4 times 2 is 8. So yeah, you can multiply. All right, so we're going to go to the next slide, and you're just going to practice. Okay, so if you notice on this slide, I kind of already started out for you. I said 1 times 4, because anything who doesn't have an exponent inside the parentheses is going to have a 1. And then I'm going to multiply the exponents. Okay, I'm not just going to multiply the ones that are the same. I'm multiplying everybody who has an exponent. That means everybody inside the parentheses is going to get multiplied by the exponent outside. Only the exponents, okay? They're the only ones that get multiplied. So I'm not going to say 4 times 3. I'm saying 1 times 4 because the 1 is the exponent of the 3. Only exponents get multiplied. So that's 3 to the 4th, and then I actually have to do the math for that. 3 times 3 is 9, times another 3 is 27, times another 3 is 81. And then 4 times 4 is 16. All right, I'm going to leave that there, and I want you to pause, and I want you to try to work some of these out. Just these little boxes right here. I did this one for you. I want you to do these over here, okay? And then we'll go back and simplify it. Okay, so right here, we did 1 times 2 for the exponent of the 6. For the exponent of the 3, we did 1 times 3 because that's the outside exponent. And then we did 6 times 2 for the m in the first parentheses. Now I did a plus sign. Why did I do a plus sign? Because remember, they're being multiplied. Multiplying exponents multiplying variables means that you add their exponents. So I put plus, and in the second parentheses, I have 1 times 3. So this is not only going to get multiplied, but you're also performing the product rule. So it's going to be added. They're going to be multiplied by whoever's outside the parentheses, then they're going to be added to each other. And then 5 times 3 because it's the only n. This one, 1 to the third times 3. Excuse me. I was trying to hit the pause button. I'm so sorry that y'all heard me sneeze. 7 times 3 and then 5 times 3. So now let's work it out just the way that we did up here. 1 squared. So that's 1 times 2 is going to be 2. Now remember that the 7 is inside the parentheses. So negative 7 times negative 7. And I should have put this in the parentheses. So like I did for negative 2. I don't know why I didn't do it for 7. But so that we can be correct on the notation of this. It's going to give me 49. And then 4 times 2 is 8. Okay, so we're going to use the calculator just so that y'all can get used to that. So it's 6 squared, and then it was 3 times 3, and then exponent. Remember, I'm using shift 6 to get that little exponent there. 1 times 3 is 3. So we got to go back into that little box of 3. So I get 972. That's 6 times 2 is 12, plus 3 is 15. And over here as well. This is negative 2 times negative 2. That's positive 4 times the negative 2 is going to be negative 8. This is going to be 21, and this is going to be 15. Okay. I want you to go to this slide. Oh, hold on, I'm sorry. This is totally different. Okay, sorry, I need to rearrange this, so I'm going to pause this real quick. Okay, here's the last one. When it says, oh, sorry, tongue tied. When the result is a negative exponent, its location will change. You cross the line and change the sign of the exponent. So here's an example of you performing the quotient rule where you're going to end up having to subtract. Well, I went ahead and did it the expanded form, and I showed you that the 3 is staying at the top. I mean, the x's are staying at the bottom. So my exponent would be a negative 3, because if I did the subtraction of the exponents like the quotient rule says, I would have gotten negative 3. 4 minus 7 is negative 3. But I don't want to have negative exponents. I do not want to work with negative exponents, so I need to make it into a positive. The only way it's going to be positive is if the 3's are the 3 x's are at the bottom, and that would make it a positive 3. Here, all I'm going to do is just make it into a positive exponent by changing, like it says, cross the line, which is let me draw it. Everybody, remember, every number and every variable can be written as a fraction by basically placing let's do this a little bit, by placing a 1 underneath it. There you go. All right. Let me see if I can move this up a little bit. So there you go. All right. Any number or variable can be written as a fraction, so we put a 1 under it. So that's the imaginary line it's talking about when it says cross the line. It's talking about when you make it into a fraction. So we're crossing the line and changing the sign. So it's going to cross this line into a 1 into the bottom, and now it's going to become a positive number because it said change the exponent. Now there's a 1 left up here because remember the coefficient of the y is 1. Now here's this one. It's at the bottom of the division line or the fraction line, and so it's going to have to cross the line, which means it's going to come to the top, and it's going to become a positive number because you're changing the sign. Okay, so on this next slide, we're going to deal with, this one. We're going to deal with more of this. Okay, we'll move this back over there. So I went ahead and skipped ahead. And what I was really wanting to do was show y'all with fractions how to distribute, how to make sure you multiply the exponent. So this would be a 1 times 3, 1 times 3. This one would be 1 times 5. Remember, it's imaginary, 1. And then this is 7 to the second power, 4, and then 6. Oh, wrong thing. Move this a little bit. This would be 6. And so we did 7 times 7. We do 4 here and 6 down here. And then I'm going to pause here, and I want y'all to try to do this one on your own. Okay, here it goes. We got 1 squared, 2 squared, because 1 times 2 is 2, and then we did negative 1 squared is saying negative 1 times negative 1, so I got a positive 1. And then 2 times 3 is 6. There's a 1 right here, so 1 times 2 is 2. All right, I already explained the negative rule, so we're going to practice that. I'm sorry, I thought that this one, yeah, I had it in the wrong order. All right, so here, remember there's going to be a 1, and this is going to be 3 to the 4th power. So I have to go ahead and do that to the 4th power. 3 times 3 is 9, times another 3 is 27, times another 3 is 81. Okay, the 1 is going to come up here because remember you're changing the line is cross the line and change the sign. So the 2 is crossing the line and it's going to change to a positive 3. So then 2 times 2 is 4 and times another 2 is going to be 8. So 8 over 1 are just 8. Okay. This one's going to be, they're both are going to have negatives. So remember that it says cross the line and change the sign. So that means the 4 will come to the top and the 3 will come to the bottom, and then they're being squared. So 4 squared is 16 and 3 squared is 9. All right, now we do this one. The A is staying at the top, so it's still going to be A to the 8th. That's the only way I can write it with an exponent. And then at the bottom is going to be B to the 5th. Remember that little caret sign right here? It just means that you're raising it to a power. So cross the line, change the sign. And then I want y'all to do this on your own. So I'm going to pause it and then put the answers back. Okay, here we go here. So the 6, x to the 6 stayed at the top, but this y had to come up to the top because you crossed the line and changed the sign of the exponent. And the z stayed at the bottom. Now e to the 0, we talked about that last time, and it's going to be a number 1. So it's gone. And then f negative 8, f is going to have to cross the line, and then we can change the exponent to a positive. Okay. All right, on this one, we're going to practice all the rules. So let's do that. Remember, this is the product rule, so we're just going to be multiplying. This is going to come out to be 21 because 3 times 7, and they're both negative, so it makes it positive. Add the exponents for the x. 3 plus 4 is 7. 1 plus 3 is 4. And 2 plus 1 is 3. Okay, let's do this one. We're going to divide. But 6 can't go into 27, but it can be reduced by 3. So negative 9 at the top and 2 at the bottom. Subtract the exponents, but there is none, so we leave it as a 1 because there's none at the bottom. There's no y's at the bottom, so we leave that as 2. Z is going to be 4 minus 3, which is 1. Okay, f is gone, so we don't have it anymore. 2 times, this is a negative 5th, so that means the 2 is going to come up to the bottom. Okay, so this is going to be, what is it? 2 to the 5th power. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 1 is 32. All right, this is negative 15. Oof. So that means it's going to go to the bottom 2. Maybe I should have taken this and put it down here. Because that's going to give us 15. But we have to remember we have to remember that we're gonna get we're gonna get 15, but there's a 4 at the top. 4 minus 15 is 11, so I'm still gonna keep the 11 down here because it'll be negative, but it's gonna not gonna be 15, it's gonna be that. Now this is a negative 1, so it's gonna stay as a negative 1 right there. I'm gonna scooch these two in together because they're gonna be together because nothing's happening to the h, so it's still 7. Let's put this exponent closer here. Let's move this up here. Ah, don't want to move that. I want to move the 32. And then move G. Ah, I don't want to move that. Stop moving. Okay, there we go. All right, so now we do this one. It's square, so it's a positive 1. Positive 1 times a negative 2 is a negative 2. This is that an 11? I guess it's. I'm thinking that's a 1. It's really hard for me to see. But okay, this is f negative 7. That's going to be negative 14. So it's going to have to cross the line and change. G is going to be 18. And then plus a negative 3, that's going to be 15. And then for h, it's going to be 3 because nothing happened to the h. All right, here 42 and then 2 is going to be negative 48, 84, I'm sorry, divided by 14. Okay, they cannot be divided because 14 doesn't go into negative 84, but they can simplify by 2. So we're going to go back and put this as a negative 42. And then this is going to be 7 because we divided it by 2. Okay, x, and then this is going to be 3 because 1 plus 2 is 3, minus 2 is 1. Okay, the y is gone from this one, but I have a 1 over here. And then from the z, I don't know why it's up there, but the z is negative, so it should come down here. Okay, and so its change is going to become a positive. All right, negative 3 times negative 4 is positive 12 times 5 is 60. 3 plus 1 is 4. There's no other ones. 1 plus 5 is 6. And then I messed up because this is the squared. So this is negative 4 squared is 16. So then it should have been 16 times 3 is 48. Negative 48. And then negative 48 times 5. Negative 48 times 5 would be negative 240. So I got to type that in here. That's not what I wanted to do. I just wanted to type on this one. Negative 240. All right, so this is squared, and then that's that. So it's going to be 5. All right, b and b5 is 6. This is going to be a squared c, and then 1 is going to be 3. Okay. Change to 4. No. What did I do? We got to go back. Oops, sorry. Just trying to see if anybody showed up. All right, and then that's it. This is the end. We're going to practice and do an independent practice before you go to your checkpoint. Okay. Bye. See you for the next one.